Only mode.
Okay. Thank you for attending RSA webinar today. My name is Artur Kosakowski and I will be running today's presentation along with my colleague Rafał Gawenda. The topics of this webinar is meshing, how to set parameters out, and how to avoid running into issues. You can find information about our new series of robot webinars under these links, and we'll also be sending invitations to you by emails. Let me start with the introduction of the concept of the RSA webinars. We'll focus on one of several topics in order to discuss issues frequently submitted to the support team. We'll begin with the general introduction of selected features of the program, and we'll develop these subjects further based on the feedback we'll receive from you after each of the presentations. Please mind that these webinars are not supposed to be the training sessions. For this webinar, we'll introduce the available and recommended meshing settings and give you some tips on how to avoid running into meshing issues caused by the way you create your models. For the next webinar, we'll develop these topics further and focus on the ways in which you can solve meshing issues when you already are in such situation. In Robot, there are two ways in which you can access meshing options. You can do so either by pressing the indicated button or use the scroll-down command menu and select Analysis Meshing. So let me switch to Robot and let me show where you find these options. Real program. So we go to Analysis Meshing, or you just press the indicated icon and you have the access to the options. The options include generation of a calculation model, which is intended for generation of the meshes for all panels defined in a model at the same time. Definition of a panel calculation model is the place where you can decide if the panel should be meshed or is just intended for load distribution only. Setting meshing options allows you to choose which kind of mesh, which meshing algorithm you want to use and what mesh density you want to obtain. Freezing meshes is the option that allows you to freeze the panels that you already generated final mesh for so that they are not adjusted during model generation. When you decide that you need to change meshes for such panels, mind to unfreeze the meshes first. Local meshing is option that you often use when you decide to mesh your model in parts, or you just want to change the mesh for one selected panels rather than running mesh generation for the entire model again. If you want to erase the mesh, you use this button. This works on the selection. Definition of emitters is the parameter of the KANG meshing, and we'll focus on that option later on during this presentation. Mesh consolidation is the option that you probably never use, but in case you want to combine two triangular elements into a quadrilateral one, you can do so. Mesh refinement, on the contrary, is the option that you may use more often, especially looking at the areas over the supports or over columns. And finally, we've got mesh quality verification that indicates the elements that are of odd shapes, and I will focus on that option later on as well. This slide shows the recommended default meshing settings, at least the ones that we propose. We suggest switching on iterative adjustment of meshing and switching off kinematic constraints, as such configuration works better for models which geometry is not perfect, has got some inaccuracies. The use of kinematic constraints in uncontrolled situations, and I will explain what I mean by uncontrolled and controlled situation in a moment, may result in errors shown on the picture, which you may find in a couple of posts on the robot forum. and also the results you obtain for uncontrolled use of kinematic constraints may be not perfect. Okay, so if I go back to the model that I've got in Robot, you can see these lines which represent kinematic constraints. And the mesh is deliberately defined in this way to show the situation where you actually should avoid using this option. As you can see, we've got a couple of beams defined at the bottom of this container, and kinematics constraints are used to match the nodes of these secondary beams. And if you now select the beam, okay, and you look at the results, for example, shear force, you can see what may happen. There are huge values of shear force which do not exist in reality. So if we now go to the job preferences and in the meshing algorithm we switch off use of kinematic constraints, we activate mesh adjustment, and also in the meshing options, first we delete the meshes and then define the defaults, like for example 0.5 meter element size for Delaunay meshing with regular mesh switched off, and then we calculate the model again, and we again select the beam that we are interested in and display the results. We can see the difference in the shear force diagram, and this time it is something that you actually expect. So, as I mentioned, this is the situation where you actually should not use the kinematic constraints. That was uncontrolled situation. The mesh was generated without you focusing it in the specific area. But here, on the contrary, there is a controlled use of kinematic constraints where I deliberately use a larger element size for walls, smaller for floors, and you can see that there is practically no difference in the obtained results. So the message is that, okay, it is okay to use kinematic constraints, but you should decide where you want to use them rather than allow the program to use them by default. And if you do, check the result carefully. Unless forced by a user, program switches between two available meshing options, Kunz and Delaunay, automatically, matching the meshing algorithm with the shape of the defined panel. And for size of the mesh, for density, we strongly recommend use of element size rather than number of divisions, as this makes the meshes coherent in the situations when you have large and small panels combined existing in the same model. Regular mesh is recommended for situations when you have bar elements that are defined close and parallel to the edges of panels to avoid odd-shape surface elements generated in between these two objects. But by default, we suggest using Delaunay method, which is contrary to the regular mesh, less sensitive to the accuracy of the model. So some mistakes are forgiven and mesh is correctly generated, whereas for regular mesh you may run into issues when you have a slight inaccuracy in the definition of the model. Kang method is often used for slabs supported by columns, and I will show such example in a moment. Okay, let me switch again to Robot, and this time I will open another model. I would like to show you how you can influence generation of mesh by settings different type of the element and matching them with the shape of the contour. So for example, if you select triangles in triangular contour, you may generate a mesh like that. If you change that to triangles and squares in triangular contour, you will obtain something different. And the most common situation, the defaults of the program, triangles and trapezoids in triangular or rectangular contour, when you have the combination of both triangular and quadrilateral elements. So if you want to have a specific mesh generated, it is also possible. You do not have to use the defaults. You may force the program to run the meshing as you like it to be. Okay. I mentioned about the situation when you have model which is like a slab supported by either point supports or columns. And this is the example when you can see the benefits of Kang meshing. Okay, let me switch back to robot again, and if I open another model, before we focus on the Kang algorithm, I would like to show you the defaults, and maybe let me go back to PowerPoint for a moment. The point is that in finite element method-based programs, the smaller elements you generate about the characteristic in the locations of characteristic points like point supports, the higher values of results, for example, bending moments you obtain. So as you know, in the software there is the option intended to average the results in these areas, which name is reduction of forces above columns and walls. And this is the option that I would like to focus on and show how it corresponds to the mesh you generate in your model. So first of all, let me select the default parameters. By default parameters, I mean like the Delaunay meshing. And if I calculate this model, I obtain a mesh like that. And if we go to the results and we display the values of bending moments with results, this is the kind of the results you obtain. And at the beginning of our presentation, I mentioned about the mesh refinement option that you may use. So how it works? If we now select the nodes that are defined at the top of the columns, so first of all let me indicate them so that my selection is a bit easier. So I go to the selection of nodes by attribute, by bars, any bar, any column. Okay, now I can see where I have the columns. I can make the selection of the elements in the areas of the columns. Okay, like that. Okay, this one as well. Now I can refine the mesh, okay? And if we calculate the model again, we can see the influence of the options. So if we display bending moments again, and we go to reduction option, you can see that now I've got a much more reasonable results over the supports over the columns. And if I delete again this mesh, I would like to use this time Kang meshing algorithm, which is simply creating these denser meshes around the point of interest automatically rather than by selection of elements and mesh refinement. So, okay, we've got this Kang method set, and as I mentioned, the algorithm requires definition of emitters, okay, user-defined emitters in this case. So I will select these nodes again, and I will open the emitters dialog, definition of emitters in the selected nodes, transfer the selection, match the size of the elements with the size of the columns, and then if we calculate the model again, you will see that I have a denser mesh around the columns, which was the intention of the Kang algorithm and is the benefit comparing to the standard meshing option. You do not have to refine the mesh. And again, of course, I mean, you may display the results, bending moments, and see the values. All right, let's move back to PowerPoint. Another point of the today's presentation is just explaining why we prefer to use element size for the definition of mesh density rather than number of divisions. You can clearly see that in this a bit exaggerated model, you have large panels supported by narrow ones. And if I load this model again in Robot, okay, you can see what is the difference when the mesh is defined as number of divisions, 5 divisions on edges on the small panels, 5 divisions for the large panel. So if you run meshing, that's not going to be done correctly. And I mentioned also about the mesh quality tool, and you can see how it works. You may use that. That's basically the detection of odd-shaped elements. You want to have nice rectangular or square elements or the triangular elements of equal size rather than long and narrow. So let me change the meshing parameters again, and this time we use half a meter size for all the panels. Okay. And if we mesh the panels again, it's much better. As you can see, again, I can run the quality check. Okay, I've got only one element. And at the beginning, I mentioned that we will focus on the solving meshing issues for the next webinar. But as the introduction, let me show you how to deal with that single elements. I do not want to mesh the panel that, apart from this location, has a fine mesh. Instead, I will just move this node by 20 centimeters, okay, and run the verification again. And as you can see, changing slightly the length of these triangle elements, I have all the elements being of good quality. All right, let's move to the next example. And this is again the something that we will develop further during our next webinar. The reasons for problems with meshing, if you ask me about number one, it is definitely the lack of accuracy in the definition of the models. It is like mind where you click or to what objects you snap, because each click when you define the contour or each element that you define, each node influence the mesh generation, and this is the results that you may have. And of course, in the situation when you have panels that have corners defined in the different location that you again are going to run into meshing. But this is the introduction, as I said, that's going to be covered during our next webinar. And at this point, I would like to introduce a couple of tips that you may find helpful. And first of all, mind that architects naturally create the models that contain all the details and our job is to simplify that. And you definitely don't want to have all these details to be transferred one-to-one to the structural model. And also the elements like short walls or overhanging parts of slabs, cantilevers, should be avoided and replaced with the corresponding loads. And putting elements with small offsets from the edges of the panels is also something that we should consider as really necessary. For the accuracy, it may be irrelevant if they are defined on the edges of the panels, but for meshing, that will be huge difference. And sometimes you use isolated nodes. You define the nodes to rotate the elements or for sake of having the modeling easier, but they are no longer needed and they are in the planes of the panels. Remove them prior to meshing. And also, when you define a model, you should consider what kind of the results you want to extract. The benefit of such approach are indicated on the currently displayed slide, and you can see them and mind that this applies not only to walls and columns as in this example, but it applies to slabs as well. So, for example, if you have a narrow strap between two neighboring openings, or you have the opening located next to the edge, replace these narrow straps with bar elements. That's both better because you've got the bending moment diagram as you intend. You can transfer these elements to the RC design modules, and also you avoid issues with meshing when you have to combine large areas with very narrow areas. Okay, let me open this model now. And I will try to show you the difference in access to the results. So I have this model calculated, and I defined two cuts at the level of the bottom edges of the walls. And now I displayed the reduced values, so that the values that you may use for design of the shear walls, like vertical force, horizontal force plus bending moment. And I mean, for the top model, the results are useless. I mean, they are calculated for the entire wall with these openings, and really you cannot really use them. But for the bottom one, you can clearly see that you have the reduced forces in the center of the bottom edge of the wall, and it is what you can use for further design. And also we can, okay, let me switch this off, and we switch the definition, I mean the detailed display as well. And if we look at the diagrams, or maybe I will just display the forces, okay? If you look at the results and maps, okay, let's change to the vertical direction for the projection of the forces, and let's display the forces. So you can see that the display of forces is maybe interesting for this part of the model where you have walls, but for column is not really what you would like to see. So if you replace them with bar elements, then you can display bending moments and axial force diagrams instead. And this is something that is needed to have the possibility to design these elements. And also, if you define these elements rather as a bar elements, you can transfer them to the design modules, columns, beams. And finally, if you look at the way that the top model is defined, it is like the larger panel with openings, and we have the linear support defined at the bottom of the entire length of the top panel. So if you look at the values of reactions, vertical reactions, you can see that, Okay, here you have a nice diagram below the wall, and you have two values of vertical reactions under the column, and this is what you need. Whereas here, this definition of the support along the openings just make the diagram to be useless. So right, let me go back to PowerPoint, and well, I mentioned about replacing narrow walls with columns, but you have to be careful, and in the situation when your shear walls are of complex shapes or just wide, using the model like that maybe the simplification going too far, and I'd rather suggest making them as vertical panels instead. Okay, finally, I would like to focus your attention of the knowledgeautodesk.com site, where you can find a couple of articles for the topics that we currently covered. And also, in general, you can find a lot of articles that should be helpful for many different situations that you may find working with the programs. So please have a look and try to search that may be really useful source of information for you. That covers, I mean, my part as a presentation, but of course we'll continue, and it's time for question and answer session. So you should be able to ask the questions using the questions tab of GoToMeeting dialog that you have displayed on your screens. So I think that we'll try to handle the questions at the moment, so feel free to ask them, please. Bo nie mogę wejść. Nie mogę wejść.
Hi, so Artur, we do have a couple of questions in the Q&A.
Yeah.
I'll just read those off to you, and if there are questions you feel we can answer here, definitely go through it. If there are things that you think will take more time, we'll just ask people to post them to the feedback page and do more research.
Sorry, I need,
So the first question...
They are not clearly seen on my panel. That's a bit of a problem.
Yeah, I'll just read them out to you.
For this. Okay.
So the first one, there was a part of the demonstration where you had a beam, and someone asked, when you cut that right beam, would that change your results?
I mean, I'm not sure that I got it correctly. I mean, this is the model where you have walls, beam, and I assume that there's a question for the model where you, okay, let me load this model. That this is the question for this model, right? And well, if you look here, there is the rigid link defined, which corresponds to the size of the beam element and the mesh. And I assume that the question is about the bending moment diagram, actually. And as you can see, there shouldn't be any problems for bending moments. We can display that. and this is the diagram of the bending moment, assuming that the beam is fully fixed, has got a fully fixed connection with the wall. I'm not sure whether that's answered the question. I hope it does.
Okay, well, we'll see if they type anything else further.
I mean, in case, let me say one more thing, that in case there is something that needs further explanation, just use the robot forum that you're probably all familiar with, and we will try to explain these questions one by one. I mean, okay.
All right, perfect. The next question, which it was answered, but I'll read it out loud for anybody that's maybe not looking at the Q&A, but do you define a rigid link at the bar end when connecting to a panel? And Francois responded, yes, there's a rigid link to make sure the beam or element is correctly fixed with meshing. Right, yep, go ahead.
I mean, that's basically the situation when the beam is, I mean, the height of the beam is considerably large. I mean, so you want to just convey the information that the transfer of loads from the beam to the wall is not done in a single point only, but is done through the entire height of the beam.
Okay. All right, next one. And this one as well, I'll just read out loud for anybody, but are the panel emitters defined to the nodes? They are a relative location on the panel. And Raphael answered that they can be defined either to existing nodes or to location. All right, we have a lot of questions coming in. So let me just find the next one. Setting different values for the tolerance in the model generation influence the meshing or not?
Say it again, sorry.
Yeah, so does setting different values for the tolerance in the model generation influence the meshing or not?
It does, but it influences a lot of other options as well. Let me put this way. Unless you can predict what influence of this option is going to be, do not mess with the default tolerance of the model generation. This is the option that has influence on many things. Of definition of meshes is one of them, but also it influences the geometry of the model. Like, for example, internally moving two neighboring nodes so that the resultant node is the middle of the original locations of these two, adjust panel geometry. So definitely, if you think that, okay, you can correct inaccuracy in the model by just putting large tolerance, you may actually make things even worse, because the results that you obtain are entirely incorrect because calculated for a model that you actually can't see, which is different to what you entered. So it is the option of the detailed correct of the model is the one to use instead. And actually, it's a good question, because that's part of the our next webinar. I will show you how to deal with the inaccuracy in the model, but definitely model tolerance is not the way to go.
Okay, great. All right, next question. Excuse me. What is your recommendation on using kinematic constraints or not?
Okay, as I tried to explain, if you, for example, want to reduce the number of elements, size of the model, and like in this example, like for example, you want to generate denser mesh for floors and less element for walls, then you can go for this option. You can select this option, but make sure that you haven't got any inaccuracy in the model, you haven't got any bar elements at the intersections, and check the generation of the kinematic constraints themselves. So only when it is done, I would do this only in the situation when I want to use this option, rather than set it as default and then check where these kinematic constraints were generated and what is the effect of them. So as I mentioned, only in controlled, in mean situation, which I mean when I want them to be defined. So deliberately I will mesh one panel and second panel with different parameters. I know that the mesh is incoherent at the edges, and I know that I want these kinematic constraints to be generated in this location, but only in this situation. That would be my option.
Okay, great. And one thing I'll just mention to everybody who's attending, thank you for the questions. When you enter the questions, you can enter them all as one continuous line. Don't worry about it being too long of a paragraph. If you hit enter, it's going to split them up, so I can only see parts of your statement separated by everybody else's questions. So just paste them all as one big piece, and I'll read those out to Artur. Okay, so a couple others that haven't been answered yet. Let me scroll down. You have a couple of good job, Artur. Great presentation.
Thank you.
And then let me go down. I'm actually going to take the ones from the bottom here. When I have a slab with drop panels, what is the better option to mesh it?
Okay, that's actually the question that has already been answered a couple of times on the robot forum. But let me explain that again. What would we do? I mean, the question is whether you consider to have any influence on in-plane forces for that. If you care only about bending moments, and this is going to be like only the thicker part of the slab, just create a panel inside a panel and with different thickness. Otherwise, just create the drop panel below the actual raft foundation and then connect these two panels either with rigid links or vertical panels like walls. So maybe,
okay. Great. All right, so here's another one. My question is with regard to the size of the mesh in relation to column size. You have suggested that the size is to be matched in your example. Is that a general recommendation?
Yeah, it is a general recommendation because this is how this reduction option was intended. Again, I mean, there used to be the post on the robot forum that I answered, and I made, I mean, first of all, for all these kind of options, my personal preference is create a small test model aside. So for example, as I expect, you would like to match the values of bending moments in a slab to with the corresponding frame model, beam and column. And what I would do, I would create this simplified frame model, looked at the diagrams for bending in a beam and check what is the value of bending moment at the edges of the column. And then I would make a couple of slab and wall simple model with different meshing, size of the meshing, and compared which size of the element gives me similar results to my frame model. But from my experience, that's usually something between half of the size of the supporter column to size of the column for mesh for element size for meshing. I would try this sort of settings.
All right, great, and they keep coming in. So let's see, this one might be a little too specific, but you let us know. I have a G+10 building. I have reduction wall from 400 to 250 from the 5th floor onward, and reduction is not centered from one face stable. So actually, I'm not sure that they have a. Is there?
I'm not sure I understand that. Let's skip that. I mean, I would like to ask the person who posted that to go with that on the forum and make some screen captures that illustrates that question. That will be a bit easier to handle then, rather than. It's difficult for me at the moment to imagine that correctly.
Yeah.
So,
okay.
so I would ask that this question to be posted on the forum. I will try to answer that later on.
Excellent. Great. Okay, next one. Is there a method for fixing torsional stresses from the beam to the panel?
No, okay, there is a method. I mean, this is the surface elements that we have in robot do not transfer torsion. So in this case, the solution is that you create either short dummy elements or rigid links between the nodes of the beam in which they connect the panel, and you connect these nodes with the neighboring elements. I mean the neighboring nodes, so nodes of the surface element generated in this area.
Okay. All right. Regarding cuts, is there a way to export or import coordinates for the cuts, just like when modifying panels contours?
Export. I mean, no. I mean, like Excel file doesn't work. If the question is how to modify that I can show. If I open my model, okay. Okay, so I defined the cuts to be at the bottom edge of the walls, but okay, you may select one of them, like for example the bottom one, and you may change the coordinate. Press -3, for example, and then you press the apply button, okay, and you can see now it is at the top. So if the question was how to change the position of the already defined cut, this is the way. If the question was whether we can like enter the definition of the cuts from external application or text file or Excel, it is not possible.
Okay. All right, and we have a lot of questions as well about whether or not the presentation will be available and the recording and where you can find everything. So to answer all those at once, yes, the PowerPoint will be available. We also are recording this presentation, so that will be available on our YouTube site as well. You'll also be getting a follow-up email. So when you registered, you put in your email information. There'll be a follow-up with information that will have the links to where you need to go to find information, put additional questions in, where the forums are. So we'll make all of that available. You'll be able to get access to that, find out what the next webinars are that will be happening. Okay, so just a couple more that aren't answered yet. And let me know, Artur, as we go through these, if it's one you've already answered. So for shear wall with rectangular columns at the ends, which is the better way of meshing it?
Okay. It's again always, let's name it reverse engineering. The question is when you create a model, you should ask yourself what kind of results you want to obtain for that. So if you want to see the results as a map for the whole shear wall, it is like create them based on three panels next to each other. If you want to see the results at the edges parts of the shear wall as the diagrams for bars, then you should introduce the bar elements at the edges of the shear wall. It's really either or, and the question is what kind of the results you want to obtain and what do you want to do with these elements. Whether you want to transfer this wall to the RC wall design module, in such case that you may, for example, create that as a single panel and make this, if necessary, increase the thickness of the edge part in the RC wall design module. So I'm afraid that's not going to be one simple answer for that. That depends on what your final objective really is.
Okay, well, that makes sense. Let's see. Can you show how you define rigid connections between concrete beam and wall?
Absolutely.
Is that something that is a short little demo?
Yeah, absolutely. That's not a big deal. Okay, you've got the rigid link option, and okay, for example, here that was the definition of the rigid links with all degrees of freedom blocked. So let me remove that rigid link from the model, and then you define the rigid link, you give it a name, and then you select the master node. In this case, that's going to be the end nodes of a beam, and you select the slave nodes. Simple like that.
Great. And this one, again, let me know if you've kind of covered this in other people's questions, but how are the loads transferred to a beam that supports a meshed panel? Is the beam automatically fixed to the panel so all moments are transferred? Or
Yes.
can you, yes. Okay,
yes. I mean, yes. Okay. All right. All the connections between the elements in robot are assumed as fixed, meaning there is the bending moment transfer. So yes, in case you want to tell that your connection is pinned, no bending moment transfer, then you have to apply releases. Okay, like for example the release for bending, for rotational degrees of freedom, and you apply that to the beam. And if you want to do the same for a panel, for example, you use a vertical panel standing for wall and horizontal one. For beam, there is the option for applying linear releases on the edges of the panel, and this is the way to tell the program that the connection between a wall and a slab is pinned, no bending moment transfer. By default, there is a bending moment transfer, with the exception of the solid, but where you don't have rotational degrees of freedom. But this is entirely different story, and I don't think that many of you are going to work with solids in robot. But in case you do.
Okay. All right. So, can I get the reduced forces above a supported node when the support is not a column or a wall, but just a supported node?
Yes. In this case, when you define a support, you need to go to the advanced parameters and tell what the real size of the support is. That's going, I mean, the real size when you define a column is taken from the properties of the bar element, from the cross-section. For a nodal support, you should provide this information as the additional attribute of the support.
All right. Let's see. In this example, when transforming the beam to bar, you must do an offset so the analytic line is on the same place as the beam of the top?
No, not really. I mean, you remember this slide where I put the comment, do not try to be as accurate as your architect is? No, not really. I mean, that was just intended to show this rigid link. But for example, if that was a steel beam of, let's say, okay, you've got like I don't know, 4-meter wall and 200 millimeters steel beam, I would definitely define that at the top of the node. So this beam would go at the top edge of the wall.
Okay, and just a clarification.
Yes.
Yeah, go ahead.
I mean that if you model that like here, you may have problem if you have stories above that, and you want to put another wall or something like that. So the TBs rather try to keep the story. I mean the story end and beginning at the same level as much as possible, even for the sake of the definition of seismic analysis later on and checking the results for the stories. So I think that the idea is to simplify the model as much as possible, but do not oversimplify it.
All right, and then when we were talking about the node connection being automatically fixed, why would you do the rigid link if the beam wall connection is automatically fixed?
Right. It is always the decision, I mean, whether you want to have more accurate results or whether you want to have your model is defined in easier way. I mean, here it is always the situation when you apply a concentrated force in a point location for a shell model. I mean, like it is the same story if you want to apply concentrated force to a shell. You may define that in a node, but again, in reality, that represents a certain size of whatever you put on your floor. So you may replace that, for example, with the equivalent surface loads. And this is the same situation that we discussed. What is the concept of the reduction of the results over the support? If you have a point support, point force applied, finite, I mean, the function that describes the elements have got this tendency of going to infinity with the values of the forces you have got in this point. So the rigid link is like the attempt to sort of average this load distribution to the larger area of the slot, rather than being concentrated on a very spot of the single point.
Okay, let's see, how are we doing on time? Oh, still have a few there. Do you think that by modeling a meshed wall between two columns at the vertical edges of it may be a rational solution in order to model a ductile wall on which the two vertical areas should be confined?
So again, I don't think this is the kind of the question that I'm prepared to answer right now.
Might need more work.
That again, let me refer again to the explanation for the size of the elements around the support for meshing. I would try to make a couple of models, simple models, and I would look how they behave, what kind of the results they produce, and exploring a couple of options. I mean, how to approach the modeling of such situation, judging by the results, I would then decide this is the closest to what I expect. But I haven't got personally made this sort of test, so I simply don't know the answer at the moment.
Okay. All right.
But definitely, my suggestion is to make a couple of models with different options, how to create this part of the structure, run the tests, check the results, and see which of the approach is the best one.
All right, great. So we have a number of questions that have been answered in the panels. I'm just going to read through some of those again just so that everybody is aware of some additional information. And thank you, Francois, Guillaume, and Rafal for answering those. So in a walls and floors model using the same mesh settings, the mesh result is different depending on the order you mesh the model. First mesh walls, then mesh floors, first mesh floors, then mesh walls. Getting tongue-tied. What is the recommended sequence of meshing? And Francois responded that maybe the smallest panels like the walls with an edge fully included in a bigger panel, a slab for example, they should be meshed first. Do you recommend remeshing the whole structure after adding panels or meshing only that panel? And Rafal responded, it depends on the model complexity. I recommend create all panels, mesh whole model without kinematic links, without regular mesh. And then I have experienced that material is not listed after. And get another response from Rafal. Meshine does not apply materials to panels. You'll have to run model generation afterwards for calculations. All right, with another question, with the model where you changed panels into bar elements, how did you connect the beam into the 3 nodes of the panel wall element? And Francois responded using the rigid link option. So 1 node is the master node at the end of the beam, and 2 nodes of the meshing are defined as slave nodes. Let's see. I mean compare with the results without emitters, and shall I always use emitters? And Guillaume responded, the emitter function allows you to use the reduction forces option. That can't work correctly if the mesh is not thin enough around the column. If the mesh size is too big around the zone, the reduction force might overestimate the reduction. All right, deleting isolated nodes only visible in the table. How can you make sure that it does not hurt your structure? And the answer, it may happen that some isolated nodes are not displayed on view, so delete them from the table. Another way is to open the file in repair mode and delete them if still existing. I think we answered the rigid link one out loud. What happens without the rigid link at the beam? Can I just connect one node? I think we covered that one as well. But again, in this situation, we assume that the beam shouldn't be pinned at the connection with the wall, and that's why we've used the rigid link. Let's see. Did have another question regarding that 400-foot wide wall with 250-millimeter mesh. Anam, if you could just put a posting into the forum. Again, it sounds like that's one that Artur and the rest of the group will want to see what your goal is and then be able to help you with that. But definitely post that there and they'll be able to take a look. Let's see. Here's another one. This is actually a question not answered yet, or actually you can let me know if it's been answered, Artur. What dimensions of concrete rectangle section do you recommend to model by nodes, and what dimensions by walls? And again, this might be one of those ones where you got to think about your end game.
I can't tell. I mean, like depend what you really model. If it is a building or if it is a part of the much smaller structure. And I mean, again, let's reverse the question. I mean, that's what I'm trying to say is, first of all, think what kind of the results you want to obtain. If you model your wall as a surface and then you want to use it for column reinforcement, that's not going to work. In this case, you simply should model this wall as a column. On the other hand, if it is like wall intended to transfer or withstand horizontal forces, defining that as a column in a single node, having a single node connection to the slab, it may also be not the best solution, because actually you need this width to transfer horizontal forces correctly. So, I mean, it's kind of the question which is difficult to answer. I mean, like 20 centimeters, that's column, and half a meter, that's a wall. I think that's the decision that has to be taken for each particular situation, for each particular model.
Okay. All right, great. And we are coming up on time. Again, thank you for all the questions. We appreciate the interest. In terms of next presentations, I will just touch on that because someone did ask, and they thank you for the presentation, Artur. It was great. The next webinar will focus on how to fix incoherent meshing on edges. So there was a question about correcting the odd shape of meshing near edges of panels. So that will be a future webinar that is planned as well.
Yeah.
If there are things that you would like to see in the beginning, actually, could you go back to those PowerPoint slides, Artur, where you had the link?
Yes.
Just so people can see that. Again, we will be making the PowerPoints and videos available, but we do have a spot where you can place some feedback. Let us know what you like about the webinars, things that you'd like to see in addition or in the future, and we do collect all of that information and work with our groups to see that.
Yeah, so I mean, definitely you can post that suggestions for the next webinars, and also, I mean, trying to answer this nodes along the edges. From the experience, that's probably the use of the regular mesh for the model where you have either some nodes already defined at the edges or in the location of the edges, or there is some small inaccuracy between in the definition of the panels. But as a first attempt, switch off regular mesh and use Delaunay mesh and see if that solves the situation. That would be the first option to try.
Okay, great. Well, if there are any additional questions that you have or didn't think of, or we didn't quite get to it in the box, the Q&A box, feel free to post those on the forums, and I will turn it back to Artur with any closing comments you might have.
So I would like to thank you very much for attending this webinar. Of course, I would like to invite you to the next one, and also I do appreciate your feedback, because that's something that allows us to make this presentation to be better and also understand what topics should we cover for the next webinars. And that's, again, thank you very much for attending.